Hi everyone, welcome back to Agentic SAP YouTube channel. So in the last four videos, we spent a lot of time testing basic text prompts and all. Today we will take a step forward and we are going to get hands-on with SAP's own proprietary models such as SAP ABAP-1 and SAP RPT-1. After that, we are going to look at prompt optimization, but there is a blocker over there, like we are going to face the limitations of trial account as usual. It's nothing new for us. But we can do everything in trial that we know already, nothing new in it. Let it not stop us. Let's see how it is being done in real world scenarios. There is an ocean of blocks out there, so let me pick the right one, show you the official architecture diagrams and explain exactly like who does what in a production project and all. Okay, let's jump into the system. Okay, so I'm inside model library. Let's start with what works first in trial account. So as I said, we'll check both SAP ABAP-1 and SAP RPT-1 models. In RPT, there is SAP RPT-1 large, SAP RPT-1 small. So first we'll take a look at SAP ABAP-1. Okay, so this is a foundation model trained by SAP on over 250 million lines of ABAP code and 30 million lines of CDS code. You might ask, where is this used in real world? SAP uses this model internally for explain code feature inside Joule for developers. uh, Java for developers we are going to see later in the series, uh, but let's just test it out here in Generative AI trial account. So it is heavily used in custom code migration projects to analyze old legacy ECC code and help ABAP consultant to transition it to modern S/4HANA clean core ABAP. Okay, let's test it. So to test this, there are two options. Like you can see this drop downs here. Like I mean, there are two options here: using chat and using prompt editor. So let's just test it in chat first. So I'm going to switch to chat mode, and there is an option to select models here. I'm just going to click on settings and choose SAP ABAP-1. Okay, it says the selected model does not support images. Selecting this model will start a new chat. So just click on apply, and I have a piece of legacy ABAP code ready with me. I'll just copy that. I'll paste it in chat box. Basically, I'm not an ABAP expert, but what I understood from it is these tables and write statements. These are old, and I think nowadays people are not using it. This is not modern ABAP cloud compliance and all. So, but let's ask um, this model and see like what is the response we get from this. So I'm just going to type a prompt also along with this code. So I'll just add a prompt. So my prompt says act as a senior SAP ABAP architect, explain what this legacy code does step by step and tell me if it complies with modern ABAP cloud guidelines. Okay, so I'm just going to click on send button here, and you can see that model updated from cloud 4.5 to SAP ABAP-1, and it says ABAP-1 does not support images. See, like, what does this response is saying? Like, it breakdowns the report definition. It is breaking down table declarations and data selection perfectly. Uh, and then it is also coming up with the compliance sections. Okay, it specifically flags the tables and rights are old, like it's no more in use. It tells us to use data access objects instead of hard-coded tables, and it actually rewrites the code using modern object-oriented ABAP with classes and methods also. Okay, so this is how ABAP-1 models works, and we can use this in prompt editor also, like by deploying that model using other options in trial account, like there is machine learning executions, deployments, and all. That should be visible in a trial account, but we are not able to see that. I mean, that is not enabled in our 30-day free trial account. For that, we need pay as you go subscriptions. So this is all about SAP ABAP-1. Next is SAP RPT-1. Okay, so I'm just gonna switch it back to model library, and there are two models, SAP RPT-1 large and SAP RPT-1 small. Okay, so this RPT is nothing but relational pre-trained transformer, which SAP pronounces it as a rapid one. Okay, let's see why it pronounces that way. So we know that a standard LLMs predicts words, okay, but this RPT, it predicts fields in a database table. Like it provides a dedicated uh, playground for us to practice. In the workbook, there's a link for it. So if we just click on this RPT-1 playground, so this is rpt.cloud.sap, and you can click on start to navigate or to get help on how to navigate through this UI and all. Okay, so what I'm going to do, I have a custom database table ready with me. I'm just going to copy it to CSV file, and there is an option here, drag and drop your CSV file here. So I'll just give a minute. We'll upload this file. Let's see like how does it work actually. Okay, I just uploaded a CSV file with the data what I had. So imagine you are an SDR sales consultant trying to predict customer churn. So what is customer churn? It simply means predicting which of our clients are at a high risk of canceling their contracts or leaving us for competitors. I mean, choosing competitors over us. So I just uploaded a CSV file with customer data, customer ID, industry, and contract value, late payments, and churn risk. So if you look at the last row, I've kept it blank and I've clicked on the set predict option. So what this RPT model does is, okay, when I hit run, I mean when I click on this predict, and it is predicting, and it says prediction completed successfully. Okay, so this model, it uses in context learning. Okay, it analyzes the mathematical patterns in our rows above. Okay, just want to click on close here. So it just took the context from the, I mean, it just analyzed the mathematical patterns and all, and from the rows above, and then it realizes that retail customers, if you look at the row also, the retail industry where contract value is 15,000, late payments are 3, the churn risk is high. And what we did, we kept fourth row is also retail industry, contract value 18,000 and late payments is 4. We want it to predict what is the churn risk, whether it is low or high. Okay. So it realizes that retail customers with high late payments tend to leave, and instantly predicts high. Okay. We just did machine learning classification without a single line of Python, and it uses 50,000 times less energy than standard LLMs to do it. So this is how it works in real time. And there are two other options. I mean, RPT-1 large and RPT-1 small. I might explore on that part, and uh, there is free trial playground for this also. I mean, I think 30 days limitations for this also, and if you just click on this link, you're going to get that. We'll deep dive into this later, but it's very high level overview, like how does it predict the database tables based on the mathematical patterns or the rows which are already exists in the database table. So regarding real world scenarios, the request for these predictions typically comes from business stakeholders and functional leads who need to automate decisions without waiting for data scientists to train machine learning models and all. So in production environment, say for example, this would be very helpful for functional consultants like finance or supply chain or sales. So sales, we just saw it, it like we can predict this customer churn, and or we need to identify like if we need to identify highest conversion leads from a new campaign and all. So we're going to use this. And in finance, if an accountant who needs to automatically assign the correct cost centers and all to new invoices based on patterns from the previous quarter, so then there we can use this RPT-1 tables. So it will just predict the cost centers based on patterns from the previous quarter, and then uh, supply chain, like if a logistic manager trying to predict which specific shipments are at risk of delay when a real-time disruption occurs and all. So for those predictions and all, like in finance, supply chain, and sales domains, this RPT is going to be used, okay, because it's an table native and understands cross-column relationships. It allows these enterprise users to get instant, reliable predictions directly from their structured business data. Okay, so this is all about SAP RPT-1. Now let's switch to what is not working, prompt optimizations. So as the name itself says, this is used to optimize prompts. Like when building real AI applications and all, you can't just rely on a prompt you just guessed, right? You need a mathematically perfect prompt. SAP AI Core automates this by having one AI grade and rewrite your prompt until it achieves a perfect score. But if you try to create an optimization artifact here, like I'm just going to click on artifact and then click on add, and you can see to select object stores, we need an EWC S3 integration with this, but there are no S3 object store registered. File upload is supported only for object stores of type S3, right? So we are getting this S3 object store error. Our trial doesn't allow us to link an external AWS S3 bucket. We don't have that admin access and all for that. So we can't upload our training data set for that. But let's look at how this is actually built in an enterprise environment. Okay, there's a specific blog which I choose for that. Uh, this is the blog. So just going to click on architecture overview, enlarging it. So if you look at this official SAP architecture diagram, on this far left, we have our object store, okay, which is holding our data set like test data.json. And then we register that object store into SAP AI core as an artifact, okay. Then we combine that artifact with a prompt template from the prompt registry to create an optimization configuration, okay. Firstly, we have our dataset ready, and then we will create one prompt template which is there in prompt registry. Then we are going to uh, combine that artifact which has dataset and prompt template from the prompt registry to create an optimization configuration. Then when we run the execution, the system evaluates the multiple prompt variants and it saves the aggregate metrics into the ML, okay. And then uh, the raw results will be back to object store, and the winning optimized prompts that will be moved to prompt registry, okay. So we have ML tracking service also to see the live progress on how execution is happening, and then we can see object store results also. Then we can save our optimized prompt in prompt registry and all. Let's look at all the steps which we need to do. We'll look at this official SAP tutorial data set called facility train.json. Okay, so what is that and all? I will tell you here. So there is this step here, prepare data set. Okay, so in this, if you see, we are going to create a data set like this. I mean, usually in real world, functional consultants will do this. So what is this data set? Nothing but imagine a functional scenario. Okay, a customer email saying the AC is broken in building 4 and we have a party tomorrow. We need maintenance and all. Um, for that, our SAP CAP backend needs a strict JSON payload to automatically trigger a plant maintenance order. But why JSON, you might ask? Because downstream system cannot progress unstructured conversational paragraphs, and they need exact key value pairs, like urgency, high, category, repair, and all. If you look at this JSON answer, like you can see there is sentiment, urgency, and criticality, and all. So those details will be coming in output. So uh, for that, facility train.json is a data set which contains dozens of these raw emails paired with exact perfect JSON response, which we expect the AI to output. Okay, so for that we need to follow some steps here. There are like 12 steps which we need to execute in the real-time project, and I'm going to tell who is responsible for each step and all. So I think first three are like, I think first five are like high level overview. So we are going to start with this register object store secret in AI core. Okay, so this basis team, our security team, they might securely links in AWS S3 bucket wherever data lives, like wherever actual data set file is there. So that will be inside object store, okay, and it will be having a secret. So basis team has to link an AWS S3 bucket to SAP AI core instance with that generic secret. Okay, so the steps on how to do this and all, you can see it here. Like we need to select the object store selection from the left hand menu, like which is not there in our trial account and all, and then we need to click on add to register a new object store secret and fill in the required details. In the secret field, use the following structure to provide your AWS credentials. Okay, this part basis team is going to do, and we registered an object store secret inside AI core. Like we established a connection between AWS S3 to AI core now. Okay, now we need to create an dataset. So who creates this dataset? Functional consultants creates this dataset. So he creates, I mean, the functional expert or business stakeholders, they will create this JSON structures. Like in our case, it's facility train.json. So they will map real customer emails to the perfectly expected JSON outputs and all. Okay, so and we need to make sure that JSON is in right format, and they're saying like verify that all answer values are valid. JSON strings following the schema defined in your prompt include diverse examples that represents various urgency sentiments and categories. If the file has this, ensure it is available it is available locally for upload in the next step. So that's how we create an data set. And then next step is we need to register the dataset artifact. Okay, I'm just gonna click on this. How we are gonna do that? So this is where we are facing an issue in our trial account. Okay, like see, what we are doing here is the AI developer, he registers the S3 path in AI Launchpad, so AI core can locate the file. Okay, so is giving that path and all here, and is selecting the GenAI optimization scenario and type as dataset and all. So is registering that dataset artifact inside uh, this AI Launchpad. Okay. So once this is done, this will be done by AI developers. So till now what we did, we created a data set, we registered object store secret in AI core, we established an link between AWS S3 to AI core, and we registered the dataset artifact also in AI core. Okay, so once this is done, I mean this will be saved as an artifact. Okay, I'll just click on yes. The next step is we need to create a prompt, and we need to create uh, a prompt template also. Okay, for that just go to prompt management. I'll show you like how to create prompt template. There is an option to create template here. So you just give your user and system message, and click on save template option here. So that will create a prompt template in the prompt registry. Okay, so there are few prompt templates here already which are created, and if you open that, there is an option here. See, optimize prompt option is there here also. I mean, you can uh, do prompt optimizations from here also. It's the same. I mean, it is navigating you to optimizations tab, and then create a new optimization job. That option is coming here. So either you can do it this way, or you can directly go to optimizations and create under the ends. You can click on create. But before that, so once you create and save the prompt template, and the prompt template. So it is saying like user role message is given as you are an helpful AI assistant, and system message was you are an helpful assistant. In system message only we will be giving the role, and user is like the real user who is giving his input and all. So in the user you can see he defined one placeholder to give the input, and is saying extract and return a JSON object with the following structure. There is urgency in the response and sentiment, and there are many other fields. So it also says your response must contain only this JSON structure, no extra text, be valid JSON, possible without errors, and match the keys and value type exactly. I mean, it should have the key value pairs. Okay, like I mean urgency, whether is it high or low. So this acts as a key value pair. Okay, and you need to click on save the template, and you need to select this scenario name and version and all. So this has this version controlling and all, which we saw like how prompt like how we can do version control in prompt management and all. So now you just click save to persist the template. Then the template will appear under your prompt registry and can be referenced by name in optimization jobs. Okay. So I mean it is saying in detail like how it will be saved as a template in your prompt registry. So we have covered till step 8. So we are ready with prompt template. We are ready with dataset artifact, and AWS S3 we have linked it to AI core. So now what next? We need to register an optimization configuration. Okay. And who will do this? This will be done by AI developer only. So what he will do, he will register, I mean, he will combine the registered dataset artifact to the base prompt template, which we created in the prompt registry. So this will be done in optimizations tab. Okay, so here in the under the runs, we need to click on create, and we need to choose this prompt optimization. It says adapt a prompt template for improved performance with one or more target models using your own data. Okay, like if you click on this, then we have four options here: select test input and select metric, then additional configurations, and then review. Okay, in select test input we have baseline prompt. We can select our prompt which we created in prompt registry, I mean the template, and then target models and original model. Like original model is the model which you have created in the prompt, I mean which you have chosen in the prompt, and the target model is against which model you have to uh, you know optimize this prompt, right? That and all. And then we can select the dataset file and metric and all. So let's see like how this is being done. So they have chosen prompt optimization tab here, and in the baseline run they have selected our prompt template, and the model they choose is GPT-4o, and the target models is Gemini 2.5 Pro, and the dataset is uh, the one which they have added in object store. And then we have an metric, select metric option. So you can see evaluation model LLM as a judge, and metric which they choose is JSON match. Okay. So what we are doing exactly here is like we are choosing the model to optimize for GPT-o and select an LLM as a judge metric like JSON schema match to grade the results. Okay. So that will like once this is all selected, and then we are going to additional configuration tab where they just selected the prompt template, and last option is review. So as soon as you click on review option, okay, the job will start running. We're just going to close this. So this is how we combine our base prompt template with dataset artifact, and we choose the origin model and target model. Okay, then our optimization configuration is ready. If you look at the architecture diagram now also, like we have almost covered 9 steps. Now we might get a clear picture. So what we did, we like we created a dataset file. In our case, it's facility try.json, and then we have registered an object store secret in AI core. That will be done by basis, and then we have created a prompt template, and that will be saved in prompt registry. And then we went to SAP AI core artifact. We have selected the path of object store where the dataset file is there. And then in the prompt optimization configuration, we combined this artifact with prompt template. Okay, now next step is prompt optimization execution, which has this ML tracking service to see the progress, and then results we can see in object store, and then optimize prompt also we can save in the prompt registry. Okay, now let's jump to step 10 now. That is how to run the prompt optimization execution. So it says once you complete review your inputs and once you complete review your inputs and click create in the register and optimization configuration set step, the optimization job starts automatically. After the job reaches completed status, you can inspect logs, review evaluation metrics, and view the optimized prompt details. Okay, how to monitor and view optimization progress? You can see that here. So we don't have that ML operations option here, but in real project, like you have to go to ML operations and then executions here, and there you can see the completed message indicates the optimization finished successfully. Okay, there uh, you can see the live metrics details and all. If you want to see the live progress, you can see it here. Like it says ML operations in your connected workspace, and go to execution tab. You need, and it will have execution ID, status, start or end time, and review live logs to check model mapping, prompt upload, and metric evaluation progress. A completed message indicates the optimization finished successfully. Once the execution succeeds, proceed to view the generated optimized prompt and metric results in the following step. So that will be like finalized optimized result will be there in optimization, and there you can see the run details, and you can see the score also, like baseline score is 84.60 percentage and optimization score is 83.5 percentage and all. So now we have compared the human written prompt against the newly generated mathematically optimized prompt. Okay, and we can check the ML tracking service to view the performance graphs and all in the ML operations evaluation, execution tab. So now we can save optimized prompt back to the prompt registry, so your custom cap application can consume it in production. So this is how true enterprise AI works. So since we have trial account implementations, I can't show you exactly how it works inside this. We need that S3 integrations and all. But hope you understand like how it works in real-time scenario and all. So we covered a lot of deep architecture today. I will attach this official SAP blogs and architecture diagrams in my free Google Form link below. So make sure you grab that PDF to study. Next video, we are taking this to next level. Okay, we are stepping into BAS, Business Application Studio, to build a real SAP CAP application that integrates with generative AI hub using the SAP Cloud SDK. Please do like, share, and subscribe so that this reaches more consultant like us who wants to upskill into AI. Okay, I will see you in the next one. Thank you.